Hi guys, so in this video we'll be looking at the straight line equation and how we find the straight line equation using our general equations. So before we get started, we'll write down two general equations we know. The first general equation is y equals mx plus c. Alright, and I'll explain what these variables mean, but I'll just write down the second one as well. This is equation 1. The second one is y minus y1 equals m bracket, open bracket, x minus x1. And that is equation 2. Okay, so these two equations are what we call general equations. Okay, general equations for a straight line graph. Alright, now what do these variables mean? So y and x are just our unknown, or in other terms I interpret my x as the input value and my y as the output value. So if you look at a graph just on the right here, okay, the x values are on the x coordinate plane and the y values on the y coordinate plane, and whatever we substitute in for x will give us a y value. Now m is our gradient. And our gradient, in other words, is our slope. Okay? Simple terms, it's called the slope. Okay? Which way our graph is going up. Is it a positive slope, okay, or an increasing slope, or is it a negative slope or a decreasing curve? Okay? And the way we find our gradient is we look at rise over run. Okay? So how much it is going up by and how much it is going across by. Okay, so this is our rise and that's our run across there. Cool, so rise over run. Alright, in other words, you can write that down as your change in your y over the change in your x. Okay, and you come up with this little basic formula, this equation for gradient, which is y2 minus y1 over x2 minus x1. So the change in y over the change in x gives us our gradient. Okay, and finally, what is c? Oops, that shouldn't have been there. I'll write that out again. Just get rid of that over there. Okay, our c is our y intercept. Okay, so where that line cuts our y-axis. Okay, so I'll write that down over there. Cuts the y-axis. Okay, or the axes. Cool, that's our y-intercept. So I've drawn this lovely straight line curve over there, and we'll actually try and find out the equation using both forms. Alright, so first of all, we've got two coordinate points. Okay, first we've got 0, 1 and 6 and 7. So first things first, let me go find the gradient. So I'll just shift it up slightly so I can use enough space to write my gradient out. So the gradient, or m, equals, okay, and we'll just have, we got y2 minus y1 over x2 minus x1. So we need to define what our x1, x2 is and our y1, y2 is. So I'll probably make this over here x1 and this is y1. This would be x2 and y2. Alright, just to keep it simple. Alright, just making sure x1 and y1 are in the same coordinate plane or coordinate set, and x2 and y2 are in the same coordinate set. Now substituting those values, so I'll have 7 minus 1 over 6 minus 0, and I can simplify that out. So 7 minus 1 is 6, 6 minus 0 is 6, and my gradient is 1. Cool. So first of all, I'll use this y equals mx plus c formula, and I'll try to find the equation using this. So I know I've got y equals 1x, because m is 1, so I can just write that as x plus c. Cool. Now, I would like to find what my plus c is. So in this situation, we know what our plus c is, intercepting the y-axis. So in our situation, we've got a coordinate over here, 0 and x. So obviously when x is 0, that's what y would equal. That's when it intercepts the y-axis. But I could just use some coordinates to find it out as well. So first of all, I substitute this point, 0, 1, in my equation for x and y. Cool. So I've got 1 equals 0 plus c. And yes, we have determined that c is equal to 1. Alright, so now I've got an equation y equals x plus 1 is the equation for that line over there. Now, yes, we did that with 1 point. We can actually find it with a second point as well. So I'll try to use the point. What was the other point we had? Was 6 and 7. Cool, and I'll actually go substitute, so that's x and y. So I will have 7 equals 6 plus c. And if I take the 6 across the other side, I get 7 minus 6 equals c. And yes, we've got 1 equals c. And we also get y equals x plus 1. Cool, so they're both the exact same. Okay, using both the different coordinates. Alright. So, now, let me go try and use this equation now. Okay, to find the equation. Now, obviously over here you found out that there is no plus c in the situation. But you've got a y1 and an x1. Right, and actually what you do is you'll substitute in a point for y1 and x1, and you'll leave y and x as it is. And I'll show you an example. So we'll use the exact same equation. We have determined our gradient is equal to 1. Okay, we use using rise over run, or the change in y over change in x, to determine our gradient. And we'll go and substitute in a point. Well, I'll use the point 0, 1 first. Cool, so I'll go substitute it in. So you get y minus 1 would equal 1. Bracket x minus 0. Cool, so just leaving the y and the x as is and substituting in for y1, m, and x1. And I'll rearrange the formulas. First I'll expand this bracket out over there, so y minus 1 equals 1 times x is just x, and 1 times 0 is just 0. Cool, and I'll rearrange the equation. So y equals x, take the negative 1 across, it becomes positive 1, and we have determined that is the equation for that line. Okay, I can check it as well if I want. So I'll use this point over here, and I'll just write down check. Okay, well that always becomes a 0, but I'll just cross that out so you know what I mean. So I'll just write down check. Whoops. Using coordinate point 6 and 7. So I'll do is I'll substitute in 6 and for x, and I'll see if it equals to 7 for this equation. So y equals 6 plus 1, therefore y equals 7, therefore this is correct. Alright, therefore this equation is true for this graph. Alright, now you could do the exact same thing using the exact same process for the other coordinate. Alright, so I will use coordinates 6 and 7 this time and substitute in. So I'll go y minus 7 equals 1 bracket x minus 6, and I'll expand it out. So y minus 7 equals 1 times x is x, and 1 times negative 6 is just negative 6. And I'll rearrange my formula, so I get y equals, so just leave y on its own, equals x minus 6 plus 7. If I take negative 7 across, it becomes positive 7. Therefore, I will get y equals x plus 1. And this equation is the exact same. Alright, so you can use any point on that straight line. It should give you the same equation. But the only thing you have to be very careful of is when you're rearranging the equation. We like writing our equation as y equals mx plus c. Okay, in this form right there, it's a nice way to look at a straight line equation. A key thing to remember when you're solving for straight line equations, okay, y and x is always raised to the power of 1. Okay, and we call these linear equations. Right, hope that helps, guys. Thank you.